Hello viewers, today our topic is to find out the motor capacity of a pump. Pump, which is most commonly used in industries and even in our home also. In our home, we are using the pump to transfer the water from our underground level to overhead tank. So in industries, it is used for the variety of purpose. And this is the general definition for the pump. Pump is a mechanical device used to transfer a fluid from ground level to higher level and to transfer long distance by increasing the pressure of the fluid or using use it for compressing the gases. So based on the required output, so the types of pumps will be differ. So considering the classification of the pump, there are two main classifications, dynamic and displacement type. Dynamic is further divided into centrifugal and special fact. Displacement is further divided into rotary and reciprocation. In this topic, we taken a centrifugal pump since it is the most commonly used pump in industries and domestic also. Based on the application, the type of pump is differ. So generally considering centrifugal pump, it is the most commonly used pump in industries. It converts the rotational dynamic energy into the hydrodynamic energy, and each and every pump is required one prime mover to rotate. So prime mover is connected in its shaft for rotation. The prime mover can be a motor, diesel engine, or a steam engine. In this topic, we consider an electric motor as a prime mover to rotate the pump, and we can see how to find out the capacity of that electric motor for the corresponding centrifugal pump. What are the parameters used for this calculation is, first one is the pump flow. So this how much flow is required to transfer from one area to another area. The flow can be in meter cube per hour or meter cube per second. Next one is the density of the pumping liquid. The liquid may be a water, fluid, or whatever it may be. Next one is the height, h. That is how much distance we have to transfer the liquid. Next one is the gravity. That is acceleration due to gravity. Next one is pump efficiency, motor efficiency, and the below parameters are the output of the calculations. First one is the hydraulic power, motor shaft input power, and next one is the motor input power. How many steps we are using to calculate the pump capacity is totally 4 steps. First step, we need to calculate the hydraulic power in kilowatt. From the hydraulic power, we can calculate the motor shaft input in kilowatt. And next step, we have to calculate the motor input power from the motor shaft power. And next step, all we know that converting the kilowatt into HP. So we can divide the kilowatt value by 0.746, we can get the value of HP. And the formulas used to calculate the pump capacity is, first one we have to calculate the hydraulic power. So in hydraulic power, just to consider whether the Q is in meter cube per second or Q is in meter cube per hour. So hydraulic power is equal to Q rho GH divided by 1000 or Q rho GH divided by 1000 into 3600. It differs on the unit. Next one, we have to calculate the motor shaft power by dividing the hydraulic power with the pump efficiency. Next up, calculate the motor input power by dividing the motor efficiency. And consider one example calculation to find out the motor capacity of a centrifugal pump. First one is the pump flow, that is Q is 120 meter cube per hour. Next one is the rho, that is the density of the liquid. Here we consider water, so 1000. Next one is the height, rotor difference head is in 45 meters. Next one is G, the acceleration due to gravity is 9.81 meter per second square. Next one is consider pump efficiency as 65% and motor efficiency as 90%. And these are the steps to find out the motor capacity. So by applying this formula, first the hydraulic power, we get the 14.715 kilowatt. By dividing the pump efficiency with the hydraulic power, we get the motor shaft power as 22.43 kilowatt. And by dividing the motor efficiency, the motor shaft power, we are getting the 25.14 kilowatt as motor input power. So further we divide that value with 0.746 to get the HP of the recurrent motor, which is 32.7, and the nearest capacity we can choose as a 40 HP. For the safety side, we consider the extra capacity of the motor, so we may consider 50 HP for this calculation. And thank you for watching this video. I believe it will be useful for you, and please like and share this video and subscribe to my channel. Thank you.